Physics, Grade 10, Monthly Review, Mid-Year Exam. Generator and Receiver. Generator. It's an electric component that produces electric energy, source of energy. Its symbol is characteristic of a generator ER. E is electromotive force, R internal resistance. The obtained curve is decreasing straight line, does not passing through the origin. Its formula is U across generator is equal minus Ri plus E. Receiver, motor. It's an electric component that receives electric energy. Characteristic of receiver E prime R prime. E prime or E small e back electromotive force, R prime internal resistance. The curve obtained is an increasing straight line, does not passing through the origin. Its formula is U across motor is equal R prime I plus E prime. Generators connected in series. Since negative pole of the first generator is connected to positive pole of second generator, then these generators are equivalent to one generator of electromotive force. So E equal sum of AE is equal to E1 plus E2 plus E3 plus etc. R internal resistance is equal to R1 plus R2 plus R3 plus etc. Generator connected in opposition. Since the negative pole of the first generator connected to negative pole of the second generator, then these two generators are connected in opposition. If E1 is greater than E2, then G2 acts as a receiver. If E1 less than E2, then G1 acts as a receiver. Electric circuit. Define an electric circuit. An electric circuit is a combination of loads, wires, switches, and at least one generator. Example. The circuit contains a generator 120 volt 0.5 ampere, two resistors R1 and R2, and a motor. Calculate the current I and the voltage UPN and the voltage across PA and AB and BN. For generator, UPN equal E minus R1I. For motor, UAB equal E plus R2I. Apply law of addition voltage and Ohm's law. U across dry cell is equal UPA plus UAB plus UBN. U across AB equal E minus R1I. UPA equal R1I. UAB equal E plus R2I. UBN R2 times I. E minus E equal R1 plus R2 plus R1 plus R2 times I. Find I, so I equal E minus E over R. Then EI equal 0.15. Now, UPN equal E minus R1I equal 12 minus 0.15 times 0.5 equal 11.92, and U across AB equal E plus R2I. E is equal to 9, R2 is equal to 10, I is equal to 0.15. U across PA equal R1I using Ohm's law. R1 4 times I 0.15. U across BN equal R2 times I, which is 5.5 times 0.15, which is 0.82 volt. Description of motion. Average speed. Average speed of motion when speed is changing. So V13 is equal A1, A3, the distance from A1 to A3 over T3 minus T1, and V02, 0, 2 is equal the distance A0, A2 over T2 minus T0. Instantaneous speed. Instantaneous speed at any given moment in time as speedometer. V2 is equal V1, 3 is V1, 3 equals the distance from A1 to A3 over T3 minus T1. Another example, V3, it is V2, 4, the distance from A2, A4 over T4 minus T2. Now, acceleration. It is the quantity used to describe the variable of the velocity with respect to time. Average acceleration A34 is equal V4 minus V3 over T4 minus T3. A13 is equal V3 minus V1 over T3 minus T1. A positive movement, we said that accelerated. Negative movement, decelerated. Zero movement, uniform. Instantaneous acceleration. A3 equal A2, 4. Before and after 3, 2 and 4 is equal V4 minus V2 over T4 minus T2. Another example, A2 approximately 1, 3 equal V3 minus V1 over T3 minus T1. A5 approximately before and after, it is A4, 6, which is equal V6 minus V4 over T6 minus T4. Now, rectilinear motion. Uniform rectilinear motion. Position x equal vt plus x0. Velocity v equal constant. Acceleration a equals 0. While uniform accelerated rectilinear motion, the position is x equal half at square plus v0t plus x0. Velocity v equal at plus v0. Acceleration a equal constant. Now, exam review. Exercise 1. In the adjacent figure, it is given that G1, G2, and motor R1, R2, and R3. What is the role of G1 and G2? G1 and G2 are connected in series since negative pole is connected to positive pole. G1 and G2 are connected in series since positive pole of G1 connected to negative pole of G2. Then G1 and G2 are equivalent to one generator, which is G. E equal E1 plus E2, 6 plus 10 is equal to 16 volt, while internal resistance are R1 plus R2 equal 1 plus 1 equal 2 ohm. 2. Calculate the resistance of equivalent resistor RAC. R2 and R3 in series. So R23 equal R2 plus R3 equal 20 plus 22 equal 42 ohm. R23 and R1 in parallel, so RAC, which is R equivalent, equal R23 times R1 over R23 plus R1 equal 42 times 7 over 42 plus 7 equals 6 ohm. Number 3. Calculate the intensity of the current delivered by the generator. U across generator equal U across R equivalent plus U across motor. Law of addition voltage in series group. So minus Ri plus E equal R equivalent times I plus R prime I plus E. Minus 2I plus 16 equal R equivalent 6I plus 2I plus 2. 16 minus 2 equal 6I plus 2I plus 2I. 16 minus 2, 14 equal I is a common, 6 plus 2 plus 2, so I is equal 14 over 6 plus 4 is equal 10. 14 over 10 is equal 1.4 ampere. 4. Reduce the voltage across motor. U across motor is equal I prime I plus E prime equal 2 times I is equal 1.4 plus 2 equal 4.8 volt. U across generator minus R1I plus E1 equal minus 1.4 plus 6 equal 4.6 volt. U across G2 equal minus R2I plus E2 equal minus 1.4 plus 10 equal 8.6 volt. 5. U across AC equal R equivalent times I equal 6 times 1.4 equal 8.4 volt. U1 equal U2, 3 equal U across AC equal 8.4. Law of uniqueness voltage in parallel connection. I1 equal U1 over R1 equal 8.4 over 7 equal 1.2 ampere. I2 equal U23 over R23 equal 8.4 over 42 equal 0.2 ampere. Now U across R2 equal I2 R2 equal I2 is 0.2 times R2 is equal to 20 equal 4 volt. U across R3 is equal I3 R3 equal I3 is equal to 0.2 R3 22 equal 4.4 volt. Number 6. When the motor is blocked, it acts as a generator. So the circuit is generator, R equivalent, R prime, since the motor is blocked, current I. And here is generator. U across generator equal U R equivalent plus U R prime minus R I plus E equal R equivalent I plus R prime I minus 2I plus 16 equals 16I plus 2I. 16 equals 16I plus 2I plus 2I, so 16 equal 10I. Then we can say that I equal 16 over 10, which is 1.68 ampere. Exercise 2. The time equation of the motion of a body is x equal 5t plus 7, x in meter and t in second. What is the nature of the motion? Uniform rectilinear motion. Since x equal 5t plus 7, it is in the form of x equal vt plus x0. Determine the speed and the initial position. Speed v equal 5 meter per second, while x0 is equal 7 meter. B. Determine its position at instant 2 seconds. When t equal 2 seconds, determine its position. X equal 5t plus 7 equal 5 times 2 plus 7 equal 10 plus 7 equal 17 meter. Now see, what is the unit of number 5? 5, and what does it correspond? 5 is the velocity, and its unit is meter per second. Exercise 3. A car moves on a rectilinear road with a constant acceleration 2 meter per second square. A. Calculate the time needed to cover a distance of 100 meter. Time when x equal 100 meter. Acceleration equal 2 meter per second square, so the motion is uniform accelerated rectilinear motion. X equal half at square plus v0t plus x0. That's 0, 0. So x is equal half at square. So t square equal to x over a equal to x is 100 over a 2, so it's equal 100. T square equal 100, so t equal radical 100, which is 10 seconds. B. Calculate its speed at this instant. At this instant, t equal 10 seconds. V equal at plus v0. V equal a is equal to t 10 second equal 20 meter per second. Exercise 4. A puck is released from a point A0 along an inclined air table. Its position is recorded at equal intervals. Tau equal 100 millisecond times 10 power minus 3, 0.1 second. Determine the instantaneous speed of the puck at V1, V2, V3, and V4 at A1, A2, A3, and A4 respectively. So, V1 approximately equal V02 equal A0, A2 over T2 minus T0 equal A0, A2 2.7 centimeter over 2 tau equal 2.7. It is 2.7 times 10 power minus 2. Convert it into meter over 2 times tau is equal 0.1. So the answer is 0.135 meter per second. Now V2 equal V13 before and after 2 equal A1 A3 over T3 minus T1 equal 4.6 centimeter over 3 minus 1, 2 tau equal 4.6 times 10 power minus 2 over 2 times 0.1 equals 0.23 meter per second. V3 V24 equal A2 A4 over T4 minus T2 equal 6.3 times 10 power minus 2 over 2 times 0.1 equal 0.315 meter per second. Now V4 is equal V3 5 is equal A3 A5 over T5 minus T3 equal 8.5 times 10 power minus 2 over 2 times 0.1 equals 0.425 meter per second. Now B, determine the instantaneous acceleration A2 and A3 at A2 and A3 respectively. A2 approximately A13 is equal V3 minus V1 over T3 minus T1 equal 0.315 minus 0.135 over 2 times 0.1, it is approximately 0.9 meter per second square. Now A3 approximately equal A24 V4 minus V2 over T4 minus T2 equal 0.425 minus 0.23 over 2 times 0.1. It is approximately 0.9 meter per second square. Part C. Deduce the nature of the motion of the puck. Acceleration is approximately constant. So the motion is uniform accelerated rectilinear motion. D. Write the time equation of the motion by taking V0 equals 0 and x0 equals 0. Time equation: x equal half a t square plus v0t plus x0 equal half a is equal 0.9 approximately 0.9 t square plus 0 so x equal 0.45 t square. The unit is meter.